Hi guys, and welcome. Can you believe? Oh, look at this, James wants to be famous. Okay, welcome to the grade 12 math session. This is Learn Extra Live. Tonight's show is brought to you by Liberty, and last week we covered financial maths, annuity, bond repayments, and sinking fund problems with Mark. And tonight our topic is Trig revision, and Mark will be taking us through it. Hi, Mark.
Fantastic. It's good to be back. Before we carry on, I just need to let the viewers know something. I was chatting to a lady who is 92 years old, and Nana Beth said to me she's watching the show today, and yesterday when I said to her I was doing Trig, she said, my favorite, I love Trig. So Nana Beth, who's 92, is going to be watching us
Hi, Nana Beth.
Oh, hello, Nana Beth. Do
How's
some
she, 92?
Trig. She also said to me one day when I've got a free moment, if I can go to a bridge club and go through the exam paper of 1943. So I look forward to that.
Yes, fantastic. You better not let her down.
Not at all.
So guys, please only call us and send us questions relating to the topic. If you stick with us throughout the year, we'll eventually get round to the section you're having difficulty with. Next week, our topic will be trig, compound and double angles. Lots of you have been asking us about our schedule, so if you are in the group, the topic next week is trig, compound and double angles. The show tonight will start off with a lesson on trig and revision. Then, after a break, we'll work through an example or two. Lastly, we'll be tackling your questions in the topic, and there are lots of ways to get hold of us. Guys, we're on Facebook, facebook.com/learnextra, also on Twitter @learnextra, so they can get chatting to me. So while you're watching, shoot us questions, and we'll get round to them in the third part of the show. We do have a Casio calculator that we will be giving out tomorrow for the best question or post on Facebook. Like I said, we'll be announcing tomorrow, and after the break, we'll be back with Mark. See you then.
See you just now.
Hi guys, and welcome back. Finally, it's Learn Extra Live for grade 12. So I know you guys are all jumping up and down. You're going, finally, it's my chance, because you've all been watching since 4 in fact. Even Matloganolo says that she's super excited for the show, and if you do know her on the page, she's the fabulous one that helps you guys out with all the questions. Mark, she's one of those ones to watch, I'm telling you. So guys, get those questions in, get posting, get learning more, and get learning extra. And before I take up too much of Mark's time, I just want to have a big shout out to Liberty, because you guys made it possible. You guys are awesome. So Mark, you know what? Now it's straight over to you. Take it away.
Thank you very much, Indiana, and hello to the viewers. Tonight, as scheduled, we're going to be doing some trigonometry. I just want to let the grade 12 viewers at home know that this is a revision of grade 11. Okay, so I'm not going to be doing the double and compound angle stuff tonight. That'll be in next week's session, so stay tuned for that. So the three things that we really want to focus on are reduction formulae, the identities, and that's proving identities, and then solving equations. Now tonight I've chosen to look at a couple of questions. I'm going to teach a concept, and then I'm going to give you a challenge question, and then hopefully, Indiana, we're going to go to an ad break, and we'll give all our viewers a chance to try and answer and then get back to you. Okay, so let's look at the first thing that I want to look at. And what we're going to do is we're going to simplify something to a single trig ratio of A. Alright, so this is the normal reduction formulae stuff. So what I want to do is I'm going to work on the side of my page over here, and I'm going to remind you of what we call the cast diagram. So if I put in here, I'm going to put a C, I'm going to put an A, I'm going to be putting an S, and I'm going to be putting a T, and hopefully everyone at home is jumping up and saying, I know what's going on. What this tells me is where my different trig ratios are positive in the Cartesian plane. So A stands for all. Everyone is positive in the first quadrant. Sine is positive in the second, tan is positive in the third, and cos is positive in the fourth. And of course, if things are positive in one quadrant, then they're negative in the quadrants where they're not positive. Makes sense? Okay. Then I also want to remind you of the reduction formulae. And quadrant 1, we're only ever dealing with, and because my question's got A's, I'll just put an A. So we're only ever dealing with angle A. In quadrant 2, we're talking about 180 minus A. In quadrant 3, we're talking about 180, okay, plus an A. And then in quadrant 4, we're talking 360 minus A. Now, I would suggest that every single one of you, those of you that want to get A's, and that should be everyone at home, that's what you should be writing on the side of your page. So you draw that little Cartesian grid, and then you put where things are positive, and you also put in your reduction formulae. Now let's go to my question, and let's see if we can slowly unravel it. So over here, the very first thing I've got is sine of 180 plus A. you need to reduce, number one, okay, to an acute angle, but you also need to worry about the sine. So let's just look at the top here. If I've got sine of 180 plus A, take it to your quadrant. So I'm dealing there in quadrant, oopsie, I'm dealing there, okay, in quadrant 3, 180 plus A. That then means that only tan is positive, so sine will be negative. So I'm going to write over here the negative sine, and I always take it to the acute angle. So that reduction formula, each one of those return an acute angle. Then I'm going to the tan of 180 minus. So I know I'm dealing with tan, and it's always going to just stay tan for normal reduction formula. I'm going to go to this quadrant, and I see in the second quadrant only sine is positive, which means that tan is going to be negative. So it's going to be the negative tan of the acute angle. Now my advice there is to put a bracket. And if you put that bracket, you'll know that you're not minusing a tan later on, but you're actually multiplying to a negative. So be careful of that. I'm now going to go to the cos of negative A. And this is a bit of a sneaky Pete. When you've got a negative angle inside, you can always do something to make it positive. And hopefully you're shouting out, what I can do is I can just say, always add or subtract a multiple of 360. You can always add or subtract a multiple of 360 to any angle without changing the value of that angle. So what I could actually write in there is the cos of 360 minus A. And so I'm going to go and reduce that on the next line. I don't need to do everything all at once. And then underneath, I have got the cos of 90 minus A. So I want to write something for the viewers at home just to follow what I'm going to do. So I've got the cos of 90 minus A. Let me write on the side of my page. If you've got the cos of 20, that is the same, exactly the same as writing the sine of 70. Okay? And if we've got, for example, the sine of 10, that is exactly the same as the cos of 80. And what you should notice is we've got here co-ratios. If you've got a sine and you want to make it equal to a cos, or cos equal to a sine, so long as these angles add up to 90 degrees, then it's okay, then they're equal. So you should always remember that as a general rule. So if I just look at the bottom, and I'm trying to remember what my question was, if I've got the cos of 90 minus A, so if I've got the cos of 90 minus an A, I can always express that as the sine of A. All right, that's a very clever trick. It's something that you learned in grade 11, but you may have forgotten, which is why I put it in tonight's question. So underneath was the cos of 90 minus A, so I'm writing now the sine of A. And now I'm almost at a point where I can start cancelling. So I know at this stage, because everything is being multiplied, I'm just going to cancel that sine with that sine. There's no reason why I can't. I've also got a negative multiplied to a negative, so I'm going to make that the positive tan of A. I don't need a denominator anymore. Now I've got cos of 360 minus. So I need to just go up my page just a little bit. And when I look up to my page, if I'm dealing with the cos of 360 minus, I'm in the fourth quadrant. That is where cos is positive. So I know that I'm multiplying by a positive cos of the acute angle. Okay. Now I'm very, very close to the answer. Very close. But hopefully at home you're shouting out, Mark, pick me, I know exactly what we're doing. You see, we can't simplify because there's tans and coses, but you can always modify tan. And you can always write tan as sine over cos. So I'd write the tan as the sine of A over the cos of A. And there I'm multiplying by positive cos of A. But to help myself sometimes when I'm not sure, stuff at the top, stuff at the bottom, I always write the whole number over 1. And then the coses are going to cancel, and that will leave me with the sine of A. Bob's your auntie, game over, we have simplified. Now, that is one example of reduction formulae, but what I want to take you through in my next example is something where you've got specific angles. And so I'm going to remind you of the special angles that you learned in grade 11 and how you can solve without the use of a calculator. So let's check this out. There is my question. So I've got the sine of 150 plus 2 tan of 135 degrees plus the cos of 240 minus sine of 135 over cos of 45. Now I must just let you know at home, the question in your exam is always going to say without the use of a calculator. And that is important because otherwise you'd just type it up. So you're going to have to use your reduction formulae, and you use your reduction formulae to write each angle as an acute angle. So that should always be your goal. Try and get any angle as an acute angle. And then number 2, when you look at the angles, look to see if you have special angles. And the special angles are things like 30 degrees or 45 degrees or 60 degrees. And I'm sure you can remember that from last year. You're saying, those have special angles. Indiana, what I've done is I've put a little red dot over here. So that's to remind me that we want to go to an ad break, because I want that to be a challenge question. So I want the students at home, they're going to have sort of like 2 minutes, so they must get frantically onto this question. They can try it, and then I'm going to work through with them, if that's okay with you.
That's perfect, Mark. I will allow you to do that. What I will also do is that I will post the question onto the page now during the break. If you haven't written it down, or hopefully you have by now, but that's okay. It's posted on the page. Guys, we're going to take a quick break. Don't leave those seats. We'll be back shortly. See you now. Hi guys, and welcome back. I hope you're all enjoying the show and you're riveted by Mark's explanations. I know I am. I'm learning lots. Remind me to show you that joke I've got about Cosby. I think a whole bunch of you have seen it. I'm going to be posting it just now. Guys, I just want to say a big thank you to Liberty for making the show happen. You guys totally rock. And I think without further ado, let's go straight to Mark. Mark, take it away.
Fantastic. Let's look at this. I'm just wondering if anyone's given you an answer. And I'm wondering, I know that Nana Beth has got a Twitter page at all of 92. I wonder if she's got an answer.
Does she?
Yeah, for sure.
Well, I hope she adds us.
Let's have a look here. I want to remind you of always doing this on the right-hand side of your page. So you draw that, what we call the cast diagram, okay? And you put in theta, 180 minus theta, 180 plus theta, and 360 minus theta. So you know whenever you're dealing with an angle, it's got to fit into one of those quadrants, and then you can take the sign out of there. It's really about helping you find the sign, positive, negative. So I'm going to go and look up here. I've got the sign of 150. What I would like you always to do is try and represent the angle using one of the reduction formulae. And I can, because 180 minus theta, I can write that is 180 minus 30. That's important. I'm just doing that to try and help you see something, and it's to help me. So 150 is the same as 180 minus 30. So then I can go and write that always as the sine of the acute angle. But I never stop there. I say to myself, okay, I've taken it as the acute angle, but I need to see if it was positive or negative. So I go back here and I say, well, in the second quadrant, sine is positive, so that answer is positive. I'm not going to put a positive because it's positive already. Then I'm going to go and say plus 2, and then I'm going to work out the tan of 135. Now again, I say, well, where is 135? That's somewhere here in the second quadrant because it's between 90 and 180. And in the second quadrant, it's 180 minus, and so I'm going to go and say that's 180 minus 45. And so I can represent this as 2 times, I'm going to put a bracket, it's the tan of the acute angle, which is 45. But before you all panic at home, I'm not finished. I want to see if that's positive or negative. So in the second quadrant, remember, only sine is positive, which means if sine is positive, then tan is negative. And I've put in a bracket again, so I remember that I'm multiplying to a negative, I'm not subtracting something. I'm going to go to the cos of 240, and now when I deal with the cos of 240, that's gone to a different quadrant. I can write 240 as 180 plus 60. And that's important. So I can represent the cos, so it's going to be plus then the cos 180 plus 60, so it's going to be the cos of the acute angle, all right? But now I must just check the sign. So if I've gone into this quadrant, 240, I'm there. 180 plus tan is going to be positive, cos will be negative. Okay, so again, I just keep my bracket. And hopefully at home you're saying, Mark's reducing things to all these nice acute angles, and the nice acute angles are special angles. Then I'm just going to go, I've run out of space, I'm just going to write a little bit underneath there. Sine of 135, hopefully now you've got the picture. Let me just change my pen because it's going to be a bit cramped here. So I'm going to write that as 180 minus 45, which then means, okay, the negative is at the front. On the top, I'm going to be able to write it as sine of 45, and it is positive, because it's in the second quadrant where sine is positive, and underneath I'm going to write the cos of 45. Now I'm at a position where I'm able to use my calculator to help me, but please remember, so I'm just going to show you something here very quickly. If I pull up my calculator, now most of you are thinking at home, hang on Mark, you said no calculator. I can use a calculator. I'm just battling with my calculator here. Okay, I can use a calculator to check. So if I go and press, let me just close the ink glass, sorry. If I go and press, what did I want? Sine of 30. Sine of 30 and press equals. My calculator is going to give me a half. Now I'm whispering because I don't want anyone else to hear, because it's almost crooking a little bit. It says without a calculator, but you can always check at each stage when you've got it to an acute angle, just check what your calculator is giving you, because your examiner likes to think that you've memorized these. So who's to know whether you've memorized or not? So we're not really cheating, but what I can do is I can go and put in all these answers. So I'm going to go over here and I'm going to put in my answer. So the sine of 30 is actually 1/2. Okay, and these are all your special angles. Plus then I've got 2 times negative something. Well, positive times a negative, surely it's just negative 2 times. Now this is another nice answer here. If I'm pressing the tan of 45, well the tan of 45 is just 1. Okay, so remember that's also a special angle. Then I've got negative cos of 60. Whoops, I lost something there. Shucks. The negative cos of 60. And the negative cos of 60, well, cos of 60 is also a half. So I'm going to be saying, let's minus another half over there. And then underneath is a bit of a sneak. And I just want to show you something very, very clever. Sine of 45 and cos of 45 are exactly the same thing. And that is the same as writing minus 1. So I'm going to go and simplify. And if you don't mind, I'm just going to put a little asterisk because I've run out of space on my screen. I'm going to come back and show you why that is equal to 1. Sine of 45 over cos 45 is 1. So now I'm just going to go and work out everything. What have I got? I got a half minus 2 minus a half minus 1. Well, half minus a half just disappears. Minus 2 minus 1 is negative 3. Now, I'd be interested to see, Indiana, if the students are getting hold of you and saying, we got that. That was our answer.
A few people have. Mick has. Mick got negative 3, so well done to him. Let's just have a look.
Well, while they're doing that, I just want to show the students something interesting. Okay. Because you might have thought, hey, Mark, how did you just leave that out? And actually, I didn't. Remember earlier on, I said to you that the sine of, I don't know, choose a number, 20 is equal to the cos of 70. If the angles add up to 90, and they go sine cos or cos sine, which we call the co-ratios or the co-functions, those will always be equal. So at the top, the sine of 45 could always be written as the cos of 45. Now I wouldn't go change the bottom. The bottom is cos of 45, and then you know anything divided by itself is then equal to 1, which is why in that step I converted it to 1. All right.
Fantastic.
I'm going to dive into identities.
Yes, go, dive.
Okay. And more often than not, students battle a little bit with identities. Now, I don't know if you can see the screen. My producer said to me it's a little bit small, but that's not really a problem because I'm going to try and remind you of a couple of things. First of all, with an identity, you have a left-hand side, which you're trying to prove equal to on the right-hand side. You can never work with both sides at the same time. You have to choose one side and eventually try and manipulate it to make it look like the other side. So you only ever choose one side at a time to work with. You can't take things over. It's an identity. Now, the other thing I'm going to say to you is more often than not, you must choose to work with the harder looking side. And that sounds crazy. It's like trying to date the ugly girl, but not exactly. When you are choosing the harder looking side, usually it's because you can do a lot. If the one side is just sine, well, you can't do anything with sine. So you choose a side where there's a lot that you can do so that you can go and simplify. Now I want to give you some strategies. And here are my strategies, which I've already shown earlier on the show. And one of the first things we should always do is convert sines and coses, okay, everything to sines and coses. So you've got a tan, write it as sine over cos. And you saw that in the very first reduction formula question, I had a tan and I wrote it as sine over cos. Also, this is just a little sneaky trick. 1 over tan is the same as cos over sine, because if you invert both sides, that's just a quick way of getting to an answer. The second point that I want to make when we do identities is so often when you are adding fractions, and I hope you remember fractions because algebra is such an important aspect of trig identities. When you add your fractions, you've got to look at your denominators and you've got to form an LCD. But in the process, we quite often cross-multiply to the numerators and we get square stuff. And that's where this baby comes in. Sine squared plus cos squared is equal to 1. You must remember that. That is always going to come up. Sine squared plus cos squared is equal to 1. And then what I've shown underneath is that identity can be tweaked and played with. So if I wanted to just get sine on its own, I could, for example, take the cos squared over and write it as 1 minus cos squared. And in the same way, if I wanted cos squared on its own, I could take the sine squared over, and that's 1 minus sine squared. And again, I just want to bring to your attention, okay, remember the big F word, factorize. Okay, so you know that sometimes you will need to factorize some things, and that's especially true when you're dealing with algebraic fractions and you want to cancel top and bottom. So always remember that if you've taken the square identity and rearranged it, that's a difference of squares. 1 minus cos squared is 1 minus cos times 1 plus cos squared. And similarly, 1 minus sine squared is 1 minus sine, 1 plus sine. And then there's one last little point that I want to make. And what I want to say to you here is that there is a third thing that we always talk about in grade 12. And we say, okay, remember, you're changing everything to sine and cos. Then you're using some algebra and you're forming LCDs and you're going to get some square identities and look to use the square identities. And the third thing I always say to my students at school is, if all else fails, look at the relationship of the angles. And you might have double angles or compound angles. And that is the third thing, and whoever's taking next week's show is going to be talking about that, because that is what next week's show is all about. How do I deal with things when they're compound and double angles? So, I'm going to dive into a question. I'm going to do this one, and I want you to follow very closely, because identities look complicated, but they needn't be. If you just do one little step at a time, just like dating, don't rush things, okay? Go slowly, you'll eventually get to the base you need to be at. And I'm going to start over here on the left-hand side. And hopefully you can see why there's not really much I can do on the right-hand side. So the first step for me is to convert this tan. And I'm going to convert tan to sine over cos. So I've got a sine of x, and I'm multiplying by the sine of x over cos of x plus then cos of x. Okay, one little step, simple as a pimple. Now I'm going to carry on a little bit further. And I know, and I try to encourage you early on, that if you're multiplying something to a fraction, okay, just put that over 1. It's a whole number multiplying by a fraction. So you remember, top multiplies to the top, bottom multiplies to the bottom. And so I'm going to end up with sine squared of x over the cos of x plus then cos of x. It's at this stage that if you've been paying attention in your algebra classes, you use that skill here. You see, I want to add these two fractions, but there's a problem because they don't have the same denominator. And that's where you've got to convert the bottom and convert the top. Look what I do. I'll just change my pen color so you can see. I'm going to say to myself, you know, put a cos at the bottom, which means I've multiplied a cos to the bottom. But the only way that the fraction is still going to be balanced and valid is if you times the top and the bottom by the same thing. And it's at this point now that I've got an LCD. I can keep the denominator and add the tops. Okay, so let's check it out. I hope I'm not pulling it up too quickly before the students can write down. So my LCD or my denominator is just cos of x, and at the top, okay, I've still got my sine squared, but now I've got a cos times a cos, and I've got a cos squared. And I just want to remind myself what I had to solve. So I know from above I wanted the right-hand side to be 1 over cos of x. And that's so important. It's a skill that you need to always remember. You don't just do an identity because you're always trying to take the left to look like the right. And so it's directed. You're going somewhere specific, specific, specific. Now look at it. Look what is the same and look what's different. And hopefully you can see, okay, the bottom is exactly the same, but the top is different, and it's come to me. Because if you've got sine squared plus cos squared, earlier on I said to you, that's a square identity. And so that square identity is then going to be 1. And so then I can go and conclude, and I can say is equal to 1 over cos of x. And please remember that you started with the left-hand side, so you must always conclude for your examiner and say is equal to the right-hand side. And then you're happy, and if you really feel like you can draw a little happy smiley face because you've done it. Okay, beautiful. So that is how we approach identities, but it's very easy when I do it. So I want to give you a chance. So I'm going to pull up over here on the screen, and there is my next challenge question. So we're going to take this down, so please quickly get your pen and paper, start writing this down. I'm going to read through slowly. What we need to prove is that we've got sine of x over, now the denominator is 1 minus sine of x plus sine of x over 1 plus sine of x is equal to, on the right hand side, 2 tan of x over cos of x. Looks a little bit more complicated, it is a little bit more challenging, but what I want you all to do is apply the rules that I've just taught you. If you've forgotten it from grade 11, and grade 11 is a long time ago, okay, try and apply the rules, form LCDs, convert the tops, try and simplify, and remember that you're trying to work to the right-hand side. Now, Indiana, I want to give them a chance with this challenge question, so if we can go to a break, they can try and do this and we'll come back and solve it.
How nice of you, Mark. That's too sweet. Okay, guys, that's exactly what we're going to do. I'm going to post this question onto the page right now. You get cracking and we'll be answering in the last bit of our show. Fantastic. Guys, don't forget to keep chatting to us at Learn Extra on Twitter, also Facebook.com/Learn Extra. We're here to help you. So if there is anything that you're struggling with, let us know. And now for a quick break. We'll see you now. Hi guys, and welcome back. I told you there was going to be a quick break, right? I bet you just hardly put your pencils down and we're back already. Okay, what I think we're going to do is we're going to post the question right now and Mark's going to start working through it slowly. If there is anything you aren't understanding, please let us know on the page. Mark, take it away.
Thanks, Indiana. I just want to remind you of that question. So hopefully for those of you that are working through, like Granny Beth, you're almost at the end and we're giving you a bit more time. You're trying to prove sine of x over 1 minus sine of x plus sine of x over 1 plus sine of x is equal to 2 tan of x over cos x. Now this is one of those interesting ones where it's quite possible, if you really wanted to take the right hand side, do a little bit, keep it totally separate from the left hand side, and then go to the left hand side and try and work it towards the right hand side. But what I'm going to do is I'm going to dive straight to the left hand side. Okay, you're adding algebraic fractions. When you are adding fractions, you need your denominators to be the same. So I'm going to show you what we're going to do here. Start off by saying the left-hand side. And so at your bottom, we had 1 minus sine of x. And then at the top, I had sine of x. Now, it might look like I'm doing nothing, but I am doing something. Okay, and then over here, we had sine of x, and we had that all over 1 plus sine of x. But now, I need to know what is the LCD. You see, it's not so simple to find this LCD because this denominator and that denominator are more than one term. It's a compound denominator. And so when you've got more than one term at the bottom, generally what you do is you take them each separately as their own distinct bracket, okay, and then we'd merge them together to form an LCD. So my LCD is going to be a combination. Now I'm going to run out of space, so I'm going to have to try to write a little bit lower. Is going to be 1 minus sine of x all multiplied by 1 plus sine of x. So that needs to be the denominator for each single term. So I'm going to go, just to help you out, and say, well, let's create the new denominator. So I know that I'd be multiplying here by 1 plus sine of x, and so I must multiply the top by 1 plus sine of x. Okay, remember what you do to the top, you must do to the bottom, and then your fraction is true. And then over here, I've got 1 minus sine of x, and at the top, I'm multiplying by 1 minus sine of x. And then I'm going to start simplifying. Okay, so we've got the same denominator, so you retain your denominator. You're adding fractions. So even if you're 10 years old and you've done fractions, you'll know when you add fractions, you keep the denominator, especially if they had the same denominator. So it's going to be 1 minus sine of x, 1 plus the sine of x, and now the top I'm going to go and simplify. And there's a whole lot of multiplying out, but that needn't be a problem. Don't panic. So I multiply the sine in, so I'm going to get the sine of x, multiply the sine to the second sine, which is then going to be sine squared of x. Then the sine is going to go in, so it's going to be plus the sine of x Then the sine is going to go into the next one, which is minus sine squared of x. Again, I'm just going slowly. Don't rush it. Just go slowly and go thoroughly. I can see something, so I'm just going to go cancel out. That's a negative sine squared, that's a positive sine squared. So I know that I've got some like terms, so I'm going to just go and write that at the top. Let's go down my screen just a little bit. Okay, so at the top, when I add sine and sine, I'm getting 2 sine of x. And at the bottom, I've got 1 minus sine of x, all multiplied by 1 plus sine of x. Now, it's at a time like this that I just kind of pause and I say to myself, where am I going? Mark, don't get lost. Don't just do things because you want to keep looking and saying, what does the right-hand side look like? Because an identity is not just simplifying, it's going to make it look like the other side. So I've got to scream upstairs here and see, I want it to be 2 tan x over cos x. Okay. So I wanted this to be 2 tan of x over cos of x. Now, again, we could panic and say, oh my word, it is nothing like that at all. And it's quite far off from where I'm at, but I can see that 2 is there. So that's helping me a little bit. I'm relaxing just a little bit without panicking. But look at the bottom. You see, the bottom is very different. And if you look very closely, you'll see that we can multiply out the bottom because it's going to give me something special. But I'm not going to fiddle with the top yet because there's nothing that I can actually do at the top. So when I go and multiply out, top stays the same, 2 sine of x. Your bottom, because it's a difference of 2 perfect squares, so I just have to multiply the first to the first and the last to the last, but if you FOIL it, you get the same answer, is 1 minus sine squared of x. Now, if you think about that, you've seen that somewhere else before. It's like that familiar looking person in the shopping mall. I've seen that, and I know I can change it to something. So whenever I see a square identity anywhere on my page, I always write out the very special identity and I go and say, well, sine squared, and this would be on the side of your page, but I don't have a side of my page, plus cos squared is equal to 1. I can always go and write that. And so then I can go and rearrange if I want to, and I can say, well, what is 1 minus sine squared? 1 minus sine squared, that'll be cos squared. So cos squared is 1 minus sine squared. And so I can convert the 1 minus sine squared with a cos squared. Now we're getting a lot closer. We're nearly there. Okay, so bear with me, almost there. And so if I just carry on, at the top, I had 2 sine of x. At your bottom now, that just becomes cos squared of x. And this is where I'm going to use a bit of clever thinking and some tricky stuff, because I want to get to 2 tan over cos. So I'm close, but not quite there. It's kind of close. So I'm going to split the cos. Okay, and I'm going to say, well, I can split this because this is 2 sine of x over the cos of x multiplied by 1 over cos of x. And you might have been wondering, well, why did I do that? Because I knew where I was going. This identity asked me to go somewhere specific. So the bottom is just still cos times cos, and the top is 2 sine. But now, look what's happening. You see, this has become, sine over cos is tan. So that is now 2 tan of x times 1 over cos of x. And when I multiply fractions, it's the top to the top and the bottom to the bottom, which then is going to be 2 tan of x over cos of x, which is my right-hand side, and we've done it. Now, I hope at home you were able to achieve the same result, and I'm hoping, Indiana, that people are saying, this is brilliant, I'm doing identities, and I can do it.
Can you actually believe that there are quite a few people saying that? Fabulove says that she can't believe how easy it is. She says, and then she even writes back, so I really can't believe how easy this is. Yeah, it's too good to be true. We've got Mahagane, he got it right as well, so well done. Let me just have a look. Kale's also got it right. And Brian, yeah, so that's like they're all, yeah.
Okay, we've got a whole lot of champions at home. Now, champions at home, I just need to do the one last thing of tonight's show, and that is solving equations. So let's have a look and see. So we're going to dive into our equations. And again, unfortunately, I apologize. Okay, this is a little bit small. I say that often to people. So when we're solving equations, one of the things you should always remember is to isolate your trig function. And every single step, I'm going to repeat 3 examples. Isolating your trig function means take everything over to the other side. It's almost like any equation and you're solving for x, get sine on its own, get cos on its own, or get tan on its own. Because ultimately we're going to use a calculator. My second point says that the sign of the ratio, so when I eventually get sine equals -2, cos equals -1, tan is -300, it's the sign, the positive or negative thing that tells me the quadrants where my answers are going to lie. And that is important. Then what we do is we use the positive ratio in my calculator. So I only ever use a positive ratio, but take that positive ratio to the correct quadrants using my reduction formulae. And hopefully saying, hey, reduction formulae, special angles, everything is connected. Everything in the world, doesn't matter what you do, links back to mathematics. Okay. And then finally, we will sometimes do this K360 part if we're going to go and solve an equation where we want to solve the general solution. Now, I'm going to solve this in a way that I think the bulk of people at home solve. But there are other teachers that teach very differently, and I quite often teach this differently in my own classes. So don't panic, we're going to get to the same answer. But again, I'm just trying to solve what I think the bulk of the nation, the 52 or so million viewers that are watching tonight's show with Grand Nanny Beth, I'm going to try and do the way that I think you taught at school. So here is an example. And I want you to please go and solve for 3 cos of 2x minus 15 plus 1 is equal to 0. I'm going to do this a little bit bigger, okay? So this is 3 cos of 2x minus 15 degrees plus 1 is equal to 0. I need to go and solve. And so what I eventually want to do is I want to get x on its own. Step 1, isolate your trig function. So the trig function is the sine, cos, or tan. So I'm wanting to get this thing on its own. Just the cos. So you're going to take things over like you've always done since grade 8 when you started with equations. So I'm going to take this 1 over to make it minus 1. But if you don't mind, 2 steps at once, I'm taking over the minus 1 and I'm dividing by 3. And so I'm going to then get the cos of 2x minus 15 is equal to -1/3. And it is here that I'm ready to go and use my calculator. And so I want you to watch very carefully what I do. Negative, okay, ratio. Cos is negative. So I know that my answers are going to be in quadrants where cos is negative. Draw your cost diagram. So I'm saying to myself, I'm going to cross off where I don't want to be. Cos is positive. I don't want cos to be positive. Everything's positive, which means cos is positive. I don't want cos to be positive. I want to see where is cos negative. So I'm there in that second quadrant. I'm there in that third quadrant. And so I'm going to use my special reduction formulae to take my reference angle into there. So now what I'm going to do, see, is I'm going to go and get my reference angle. And this is where teachers sometimes say it's the reference angle, the key angle, or the acute angle. It's all the same, reference, key, or acute. So now when you find the reference angle, only use a positive ratio. So what does that mean? Don't put a -1/3. Don't ever put in a negative. You just put in a positive. So I'm going to pull up this calculator. Okay. And what I'm going to do, because I am dealing with cos, okay, don't worry about the other stuff. I'm going to go and press the shift cos, because that's telling me I want an angle of positive 1/3. So I'm going to put in there 1/3. And I'm going to close my bracket and press equals. That is my reference angle. That 70.528 blah 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 is the reference angle. And we never ever ever want to round off here. You only want to round off your final answer. So I know it's 70.5 something. So let me just write over here. It's 70. Okay, let's just get my pen. 70,5 and I do dot dot dot. But what I am going to do quickly on my calculator is I'm going to store it, because I don't want to have to ever memorize or keep all the decimal places. And all scientific calculators will work in very much the same way. So I've got a button that says store. So I'm going to press shift so I can get the yellow, store, and I'm going to store it into position A. Which means if I ever want to call that up, I'm just going to recall A. Okay, so remember, it's shift, store it into one of those letters A, B, C, D, E, F, and so on. Now, I'm going to go and solve, but I must just be very careful because the signs told me my quadrant, so I know that I'm dealing in quadrant 2. Okay, so quadrant 2, sorry. Okay, QAD, quadrant 2 is going to be my angle, 2x minus 15. And in the second quadrant, it's always 180 minus whatever the reference is. And because I'm going to do a general solution, I'm going to put plus K360. Now it's exactly the same as what I would do. I'm going to come back. This reference angle is actually the A on my calculator. All right? So I've taken it into the second quadrant. What I'm going to do is I'm going to try and eventually get X on its own. So you slowly take stuff over. I'm going to take the 15 over and add to that answer. And then I'm going to divide everything by 2. So I'm just going to show this little step. So if I go and eventually get X on its own, it would have been 15 plus 180 minus the reference plus K360. Let me just move that over a little bit. And to have got X on its own, everything was divided by 2. And so now I'm going to use my trusty calculator to go and solve that for me. Okay, so my reference angle is A. So I'm going to go and press a fraction. So it would have been 15 plus, open your brackets, it was 180 minus my reference, 180 minus, now my reference angle was A. So I'm just going to say, call up A. The calculator has always stored that angle and it's never going to go. And then this whole thing is over 2. And so when I get to this answer, it is at this point that you're allowed to round off, because here I'm going to go, and my question didn't say how many decimal places, but I'm going to go to one decimal place, and I'm going to give an answer of 62.2. So this answer is 62,2 plus K180. And there's something that I want to bring to your attention. That there. You see, when you divide the whole side by 2, in the process of solving, so I take the 15 over and then divide everything by 2, you must remember that this K360 is also over 2. And so dividing the 360 by 2 is going to give you K180. Alright, so that's the first of the 2 answers. I'm going to go a little bit quicker now. To get to the second answer is where I'm going to go now to quadrant, just trying to remember where I was. I think I was in quadrant 3, or quadrant 3. So remember that quadrant 3 is going to be whatever angle I've got, 2x minus 15. And that is always in quadrant 3, it's 180 plus. So I'm using my reduction formula. So I'm plussing the reference angle, which is my A on my calculator, plus K360. And then it's just a matter of putting in a calculator and going to simplify. So I'm going to add 15 to this when I take the 15 over, plus the reference, plus K360. And I know that in order to go and get X on its own, I had to divide everything by 2. So now it's just pull up the calculator and bob's your auntie. So 15 plus, let's go and put over here, it's going to be 180 plus my reference angle. Remember, I stored the reference angle in A. So it's always, the calculator is never rounding off, it's always keeping that reference angle. Divide everything by 2, press your equals, and if I go to one decimal place, so read off your screen, it's here that you're allowed to round off, 132.8. To one decimal place, 132.8. Oopsies. 132.8, and that again is plus K 180. Okay, now that's shown the first equation, and that takes you through the whole of grade 11 equations. But what I want to do is I want to pull up a question which is going to be my challenge question, And there is a challenge question which says, use a calculator to determine the solution for x. And instead of a general solution, what I have now given you is an interval. So you're going to solve for an interval. And Indiana, I want to make this a challenge question again for our break. So I just want to read it for the viewers at home. You're solving 2 sine squared of x minus sine of x is equal to 0 for a specific interval. And I want to give you one little hint before we go to the ad break. Please remember that you're solving an equation that's not necessarily linear. Sometimes when you get something that's non-linear, like a quadratic, you have to factorize. Okay, so remember, you might look to factorize to do something specific here, and always go and answer to get me in those specific intervals.
Okay,
Indiana?
fantastic matrix. I will post that during the break. As you can see, Mark has given you a few sneaky tips, so hopefully that will help you along your way. I just want to say, Kashifa said on the page, come on matrix, how many students are here? So guys, if you are watching Mindset Learn, let us know on the Facebook page, Facebook.com/Learn Extra. Just let us know if you are watching and if you are understanding. So far, it seems like you're all loving it. I know Anele said, I've never been good with Trig, but this time around, I'm going to nail it. Thanks, Mark. So excited. So guys, get working on that question, and we'll see you now after the break. Hi guys, and welcome back. We are heading into our last 10 minutes of the show, 5 minutes even. I can't believe it. Okay, we're not going to waste any time, because I can see Mark's getting a little bit agitated, so we're going to get straight to him. Mark, take it away.
Thank you very much, Indiana. I'm going to dive into this, and I'm probably not going to be able to solve it completely, but I still want to show you the subtle tricks that you need to know here, because your ability to solve this kind of equation is going to underpin everything in grade 12. So when you look at this, you should say, well, I can't isolate the trig function very easily as it is, but we can factorize. And so always remember, when you start factorizing, you're looking for a common factor. You might be looking for difference of squares, you might be looking for a trinomial. And I can see there's a common sign. So if I take out the common sign, I go and look and say, well, what is left? Which is going to be 2 sine x minus 1 is then equals to 0. And then you treat that as a quadratic, because a quadratic says to me, if you've got the product of any two things, and that's true for a cubic as well, the product of your terms equaling 0 means that that one is 0 or that one is 0. And so I'm going to unravel them, but I'm going to do them independently. So I'm going to do the one, and then I'm going to go to the other. Now I'm going to fly through the sine x1, because that I think is a little bit easier. And so I would then go and say, well, sine of x is equal to 0. When I go and put this on a calculator, and if you go and look, if you have any idea of what the graph looks like, okay, when is sine of x going to be equals to 0? I do shift sine, so let's go and press, okay, if I just go and press the shift sine of 0, okay, and that's going to give me 0. And so I know that it's cutting at 0, and it's cutting at 180, and it's cutting at 360. So you can do this very easily. It's not too difficult. And what we do over here is I would then just say from a calculator, x is equal to 0 plus k360, or you can also say x is equal to 180 plus k360. But my real focus is going to be, how do I go and solve the other part? So if I go and solve the other part, remember all the rules from earlier, isolate the trig function. So you would go and say, well, 2 sine of x is equal to 1. So therefore, the sine of x is equal to 1/2. It's at this point that you can go and use a calculator. And so now I know that I'm dealing with something that is positive. And I draw my little cast diagram, because my cast diagram tells me where everything is. Okay, and the cast diagram says that I'm in the first quadrant and the second quadrant. So in quadrant 1, it is always just going to be my reference angle, and I happen to know this one. It's a bit of a cheat, it's a special angle, so this will be 30 degrees plus k360. And then if I go into quadrant 2, remember quadrant 2 always takes your reference angle into that quadrant, which is 180 minus. So it'll be 180 minus 30 plus k360, and then that will give me x is equal to 150 plus K360. Now, I know that I'm not going to have enough time, unfortunately, but this particular question said, please solve for this interval. And all that I do now is I'd substitute different values of K. So I'd say, for example, make K naught. So when K is naught, this answer would be 150, which is cool. When K is equal to negative 1, I'm going to have 150 minus 360, which is what going to be 210. Negative 210, which is also K. And then when I say K is equal to 1, I'm going to have 150 plus 360, which is going to be 510, which then I would have to reject. So when you're taking a general solution for a specific interval, you substitute different values of K and see the solutions if they fit within your interval. But that's all the time that I have for me. I've got to say goodbye, and I'm going to hand over to Indiana to wrap it up. Indiana.
Okay guys, thank you so much for joining us, grade 12s. We had such an amazing lesson, and thanks so much for Liberty for making this possible. You guys rock. Guys, keep helping each other out on the page. I think that's the best way to do it. And stay tuned for next week. Thank you so much for being so awesome. Always learn more, learn extra. See you next week. Bye.